Welcome to this episode of Spacetime Fika, a podcast about physics and astronomy. My name is Jonas Enander. I have a PhD in physics and currently work as a science communicator in Stockholm, Sweden. And Sweden is also my home country, which is reflected in the name Spacetime Fika. The first word, spacetime, stems from Einstein's theory of relativity, whereas the second word, fika, is a Swedish word about a very central activity in Sweden, namely to have a social coffee break, a fika, together. The goal of this podcast is to meet people from the world of science and discuss in an informal way, like having a fika, what we know about the universe and how we have figured that out. The topic for today's episode, however, draws us closer to Earth. I discussed the relationship between astronomy and colonialism with Dr. Ann Thresher, who is a postdoctoral scholar from Stanford University. Thresher merges her expertise in philosophy and physics to explore ethical questions in environmental and space sciences. She's working on the social and political dimensions of telescope sighting as part of the Next Generation Event Horizon telescope. And she brings a unique perspective on how astronomical advancements can intersect with very deep issues relating to land ownership and indigenous rights. I hope you like this episode. Okay, welcome to this episode, Ann Thresher.
Yeah, thank you for having me.
It's very nice to have you here. We are going to talk about the ethical aspect of telescope sighting and also the ethics of astronomy in general. But to begin with, we will talk a bit about your background, like who are you?
Yeah, so I started out my academic career doing a physics degree and a philosophy degree simultaneously at Sydney University. I've always been really interested in how the universe worked, and I figured those two degrees would be the way that I would get access to the universe. And I quickly realized I didn't want to be a physicist, but I still loved physics and all the things surrounding it. And instead, I ended up doing a PhD in philosophy of physics. And throughout that sort of PhD journey, I actually ended up deciding that I didn't want to be a philosopher of physics. So instead, I ended up in the environmental ethics space. I decided I really wanted to work on these like fundamental questions about like how to save the world, basically. Climate change and these issues are one of the most pressing things sort of encroaching on humanity. And so nowadays, I'm a researcher at Stanford, where I'm actually hired by their sustainability school and the McCoy Family Center for Ethics and Society. So I do a lot of stuff on environmental technologies these days, and particularly synthetic biology, and de-extinction, reintroduction, genetics. I ended up sort of circling back around and getting back into physics a couple of years ago when I got in contact with some people working at the Black Hole Institute at Harvard, who were some friends of mine who were working on questions of astronomy and the philosophy of astronomy. And one of the big questions that they ended up sort of posing as part of this conversation we had was thinking about the ethics of astronomy, and particularly these issues that astronomy's been going through centered around places like Maunakea, where it's turned out that astronomy has just historically, perhaps to no one's surprise, not been great about thinking about the ethical impacts of the work it's been doing. Especially when it comes to the fact that astronomy often works in places that have histories of colonialism, that are in the global south, that have histories of economic and scientific exploitation and extraction. We had these like very interesting conversations about what astronomy was doing. And as a philosopher of science, as well as an environmental ethicist, I'm really interested in the way that science and technology can both benefit humanity and do harm, even as it benefits humanity. So we ended up having these really interesting conversations, and I ended up getting looped back in to sort of think about the ethics of astronomy. So nowadays I work as part of the responsible sighting group for the Next Generation Event Horizon telescope. So I co-lead this group with two others, Daniel Palumbo and Luis Reyes Galindo, who are both phenomenal human beings. And the three of us together have sort of sat down and thought long and hard about what it means for astronomy to be an ethical field.
Right. It sounds amazing, and a lot to unpack there of what goes on in your work with the Responsible Siting Group and also your academic work. So let's take a step back and look a little bit about what you said here about the ethical side of astronomy. So I think most people, when they think about astronomy, they think it as a very pure kind of research, just learning more about the cosmos, and it's kind of floating above the everyday concern of humans. But that's not really the case, right? So
yeah, I hear this a lot from astronomers in particular. When you talk about the ethical aspects of astronomy, they tend to think very big and about these amazing things that astronomy does do. It's telling us about the universe, about the stars, about black holes, and our place in this like grand scheme of things, which is brilliant. As a physicist, I think this stuff is incredibly important for us to pursue. But astronomy, I think, has come to a very harsh realization, especially post some of the issues that have happened with some telescopes across the globe, that they're not as divorced from the rest of society as they like to think they are. And this is a transition that's happening throughout science. If we look back at things that were happening around World War I and World War II, science sort of became this force for both positive things and with things like the nuclear bomb and mustard gas and these other revolutionary changes in science, there came this recognition that science, in fact, changes societies and is impacted by them. And in turn, itself is impacted by what society wants and how it responds to these things. And so there's been a long conversation that's happened over the subsequent years about what science is and how it works and what its obligations are to the societies around it. And so the astronomy thing is really just the leading edge of this in physics, as we start to recognize that astronomy isn't divorced from the people around it, that especially something like astronomy, which relies heavily on telescopes, these sort of very place-based objects, it's not often, or sometimes it's done in labs, but a lot of the big discoveries happen out in the field in collecting the data. And those locations tend to be places that are high, they tend to be places that are remote, and both those things tend to be very spread across the globe. You need very long distance between your telescopes in order to make observations. And all those three things combined tends to mean that the places we build telescopes are often remote, tends to correlate to poor or not well represented by governments. It tends to mean in many places indigenously owned, or at least traditionally owned by groups that may have been displaced from the land. It might mean national parks. It often means mountains, which tend to be more culturally significant to many groups, whether that's because of their aesthetic preferences, because their religious background, because of their use, even just as a hiking space, right? These things tend to sort of draw the eye. And because of this sort of dispersal of telescopes, it tends to be in places like the global south. Very few places in the world have not been touched by colonization. And science has a long history of being a part of that colonization. And so astronomy is this interesting nexus of all of these things that sort of make it a perfect storm for these ethical worries. So when astronomers go into a place to build a telescope, historically they've just gone in, asked local government, gotten the university involved, and just built something once they've got the funding. And that fails to recognize the environmental impact of these buildings. You're often bulldozing roads to the tops of mountains. Mountains tend to be very rarefied ecosystems. They tend to be very unique. It also tends to ignore the traditional owners of the land, the people who might have emotional or social or religious or cultural connections to these places. And it tends to ignore the local communities that surround these places, which may well be negatively impacted by the telescopes. Perhaps most obviously, some telescopes require you to have, for example, radio silence around them. You have zones where you're unable to use radios or mobile phones. And so some telescope locations, they set out huge radiuses where people aren't allowed to use these technologies. And that'll often include local communities. And so we're asking a lot of these people as we go in to build these telescopes, whether it's simply the resources, ask them to help us build it, asking them to let us take the land and use it, and asking them to a certain extent participate in the kind of science we're doing by not doing light pollution, by not having radio wave pollution. And so there are all these really complicated connections that happen in the astronomy space that means that as much as it's nice to look to the skies and say we're doing positive, amazing things up there, that work has to be grounded in what's happening around the telescopes themselves. And a lot of the work we're doing in the Responsible Siting Group is thinking about those impacts.
Right. So, and just for the listener, you mentioned that there has to be a long distance between the telescopes. So that was specifically for the Event Horizon Telescope, right? Yeah.
Yeah. So some telescopes don't require long distances, but it's also the case that we need to put telescopes often in high up places, and there are only so many mountains that have the right kinds of elevation and also atmospheric conditions. Very few of those are going to be in Europe, for example. Most of them will be places like Africa, like Hawaii, some places in New Zealand, these areas that have been colonized.
One of the places you mentioned now was Hawaii. So what was it that happened there that makes this place so well known in this context?
Yeah, so Hawaii is perhaps the most spectacular example of why astronomy needs to care about the ethical siting issue. So Maunakea is one of the tallest mountains in the world in Hawaii, and it happens to be perfect for astronomy. It's very tall, it has great weather systems, not a lot of water in the air. And so it has a number of telescopes already built on top of the peak. Now, a few years ago, about a decade ago, a bunch of astronomers proposed to put another telescope up there, the 30-meter telescope, also known as the TMT. So the TMT is one of the biggest telescopes proposed in the world. It has phenomenal potential for observations into space, but it ended up being this flashpoint for conflict in Hawaii for a wide range of reasons, ranging from the colonial history of Hawaii. It was seen as sort of this, like, in many ways, I think, a symbol of the ways that the government doesn't respect or think about traditional owners of the land there. Hawaiians have a very important cultural and religious and heritage connections to Maunakea. And they felt like these places were being disrespected. And they didn't have a say in who was putting these telescopes up there. And so what happened was this series of protests against the building of the TMT. It escalated in ways that I think no one was really predicting on the astronomy side, and basically halted construction. So to this day, there's no ground been broken for the TMT. It is still in a holding pattern. And there have been ongoing conversations between the astronomers and local Hawaiians about what building it might look like, why it's a bad idea. And because we're coming in so late to the game in Hawaii, a lot of the trust is gone. There's very little sense that the Hawaiians feel like they've been listened to. And it's a good example of why not thinking about these things can lead you to trouble in astronomy. And in fact, it's had large knock-on effects for astronomy, not just because we're now seeing groups like mine, which are thinking about responsible siting, being integrated into building telescopes, but it's really damaged the reputation of astronomy as a field and had knock-on effects where other telescopes having trouble getting funding or are being blocked by groups because they've seen how badly astronomers have handled things with the Maunakea situation.
So concretely, what was it that astronomers should have done differently in that case? What did they do wrong?
Good. So this is a very complicated question and one that we're trying to sort of think through as part of the responsible siting group. I can give you sort of generalized answers to this, but the real answer is that any given situation is going to be very different, and Maunakea is no different. So the general criticisms I've seen and that we're sort of thinking about in the group is that there wasn't really any permission asked from locals. What permission was given was taken through the University of Hawaii. So the assumption was that if the academics are on board and if like local leaders are on board, then it's totally fine. No one even, I think, thought to ask or check how everyone else on the island felt about these things. So there are a lot of lessons to be learned from Maunakea and more generally from science. Astronomy is not the only field that goes through questions of responsible siting. There are areas of biology, in my own other work, synthetic biology thinks a lot about where to release genetically modified organisms and how to ask permission from those in the community about these things. Archaeology and paleontology go through these questions. And so we can draw lessons from what they've been doing to think about what might have been done better at Maunakea. And that includes getting the community involved as early as possible. It involves listening to what communities want rather than just assuming that you know what they need. It involves integrating locals into the process of building and thinking through even just astronomy in general. There's often a mistake made in science. We think that scientific knowledge is distinct from traditional knowledge when in fact they're continuous, right? Europeans in the West don't have a monopoly on astronomy. Every culture is looked up throughout the entire course of human history. And many places across the world have very rich and valuable astronomical knowledge. And so especially in the Maunakea situation, there became this demonization between science and what was seen as traditional, or like in many ways referred to as backwards knowledge, like sort of like religious mumbo jumbo, when that was not what was happening. But there was this strong line drawn between these two groups and the vilification of locals along those lines that was just not productive at all. So Maunakea, I think a lot of the lessons learned from there are just you need to listen to people. You need to be proactive about giving information and being willing to hear no as well. So one of the big things we've been talking about in the group a lot, and I think it's important for Maunakea and for every sighting group, is it's not just about listening. It's about being willing to change your mind about things and to hear when groups don't want you in somewhere, because there's no point in going in and asking permission if you're not really asking permission, if you're just looking for a yes or you're trying to fabricate it, which I think is what astronomy has traditionally done in a lot of these places. You just keep asking until you get the yes, and at which point you go ahead. And so consideration of what that looks like in Maunakea, I think ahead of time would have gone a long way to mitigating these issues.
Right. So looking forward, then there are different telescope projects planned in different parts of the world, and there is an ongoing work now to involve local communities at an early stage. But what happens then if a group in a local community says, no, we really don't want another telescope here. We're not against science. We love astronomy, but it's going to be environmental impacts or social impacts, or the mountain has a special status for us. We don't want this. What should astronomers do then?
So it looks like a very simple question in some ways, and it's actually a very deeply complicated one, because part of the complexity of figuring out responsible siting is figuring out what a yes and a no looks like. So no community is homogenous. You're going to get people who strongly disagree with basically anything you put before a community, and people who strongly agree with it. And so a lot of what it is to think about these problems is to work with groups like sociologists and ethicists to think about what our ethical obligations are to these communities and figure out how to recognize yeses and nos as and when they occur. So, I mean, the real short answer is like, if a community says no, don't build there. It's just, when we build telescopes, we're basically asking permission, where these people are hosting us as we come in. And the recognition that we can't repay them by saying things like, isn't it wonderful astronomy is doing amazing things, right? Like, you should be in awe of the work we're doing. You should be grateful that we're putting a telescope in. Like, that's the wrong attitude to go in with. I think it is a common attitude. Instead, we have to recognize that these communities are giving us something when they allow us to build that, whether it's access to roads, whether it's resources, whether it's local knowledge, whether it's even people who like actually physically build the telescope or work there. They're hosting us. And so if they're not willing to do that work, we shouldn't be forcing it out of them.
Yeah, it's a very important point. And do you feel that funding agencies and astronomers who are involved with this, are they incorporating this point?
Yeah, so I think it is shifting within the field. For all that Maunakea has been an absolute disaster in some ways, one of the positive things that's come out of this is astronomy is starting to think really hard about what it wants to be as a field and how it wants to interact with local communities. So funding bodies are starting to require more stringent assessment of community impact for these sorts of projects. They're asking the astronomers ahead of time to confirm that these are places that actually do want the telescopes. And then we see things like the NGHT where I work, where they're...
What's the NGHT?
Sorry. So the NGHT is the Next Generation Event Horizon Telescope. So this is a group that's looking to build between 10 to 12 telescopes over the next decade or so. The initial ones will be albeit sites that already have telescopes on them, and then there'll be a bunch of new sites that we're talking about ramping up. And we're still in the decision phase. We're trying to decide where some of the new sites are going to be. That's part of my work with the group, is figuring out what the social and environmental impact of these telescopes might be, to try and give advice on where we should be aiming to build these telescopes, and how to work with the communities around to double check that they're on board for this, then work with them in productive ways so that it's a mutually beneficial relationship. So things like the Next Generation Event Horizon Telescope are starting to bring ethicists and social scientists and people outside of physics who have expertise in these topics in early. And that's really the best way to go about doing this for astronomy, is to recognize that there exist people who have these expertises and can do this work for them. And the earlier they're involved, the more likely you are to be successful at it.
Yeah. So is there an example of where this has been done and it actually worked in a quite good way?
I'm not sure I have clean and good examples of where this has worked really well in astronomy. I'm still looking for like the one example you're like, absolutely unproblematic. Like, we've solved this, it all went really well. Partially because historically, as we've built these telescopes, people have just sort of steamrolled over objections. And there are not records of people objecting to these things. We don't really know for a lot of these older telescopes, certainly, like what objections might have happened on the ground or how people felt about it at the time. But there are certainly better and worse ones. So take, for example, the square kilometre array being put in Australia right now. The Australian government has just finished up negotiations with local Aboriginal groups out there. And that was a 5-year process where they sat down with these groups and recognized that the square kilometre array, which is different than some of the telescopes we're talking about in my project, which is like single individual telescopes scattered across the globe. Instead, we have a huge array of telescopes over an extended acres and acres of land in the desert out in Australia. And so the government was very proactive about making sure that they were getting permission from local groups, that they weren't infringing on sacred grounds, on traditional heritage sites. They had archaeologists in to make sure that anything that was found was like recorded and taken care of. And so that sort of work, I think, is incredibly like promising. I think this recognition that we need to be talking with people, it is happening in some parts of the world. And astronomy is starting to pivot to being, in many ways, actually, I think, one of the more promising areas of physics for this. Physics is not traditionally thought much about its footprint as it does its experiments. And I think astronomy in many ways is well placed to be a leading example for the field, for what it looks like to think about your own impact on the world around you and to do that in the right kind of way.
So one of the changes people have been talking about is that now we have examples of looking into sites, looking at archaeological projects, and so on. But what about also changing the demographic of who has access to these telescopes? Because if you build a telescope on a mountain, it would feel kind of natural that people living there would also be able to use the telescope. But often that's not the case. Often it's people flying in from abroad using this very advanced equipment. So is that on the table too, to actually start to change the demographics around these telescopes?
It's definitely part of the conversation that astronomy is having right now. In some places that looks like when we build telescopes in places, funding local PhD students, doing science outreach for local school kids, that sort of thing, and like getting people sort of trained up and having more access to astronomy as a field, which I think is valuable, not just local communities, but to astronomy as well. There's a lot of work on why diversity inside science makes a huge difference to how reliable science is, to the kind of advancements that get made. Matter of fact, there's some studies that have shown that diverse people in the field tend to lead to scientific revolutions more often. So it's good for astronomy to bring in diverse groups, but it's also good for the people on the ground who, as you say, feel more connected to what's happening in these areas. Because, astronomy, traditionally, you fly in, you make your observations, you fly, and you may not even do that these days. You may have a lot of remote observation. These things are run by robots, essentially. And that, in some ways, is even worse, because what happens is you get a bunch of people sitting in, an American university taking observations with the telescope, while you basically hire people on the ground in the local communities to be your janitors, to come in and do like repairs and like clean up after the place. And like, that's not the kind of benefits these communities would like to get from these sorts of technological advancements.
Yeah. And what about the end life of the telescope? Because you build a telescope, you use the telescope to produce data and do science, but it also has a finite lifetime. So how do you restore the place when the telescope is done?
Yeah, this is a thorny question. It's not something that's been talked a lot about in astronomy. Some telescopes have been decommissioned, but often that's a post hoc decision, and the funding for it comes well after any funding for building the telescope. So very rarely when you're building telescopes do you think about the decommissionment costs, which can be in the millions of dollars to bring a telescope back down again and restore these ecosystems and these spaces for the local communities. So it's something that the astronomy needs to start thinking about, I think is starting to think about. But to be honest, like a lot of the conversations I've had with people are about how it's hard enough to get funding for the telescope in the first place, let alone set aside millions for bringing it back down again, 10, 20 years from now, which is the complexity is increased by the fact that often these collaborations disappear in that time. The telescope may outlast whoever it is that built it in the first place. And so you end up in this really complicated space where it seems like the people that build it certainly do have an obligation to figure out how to bring it back down again, but it may well be that the obligation rests higher up with the funding bodies. So looking at how things like the National Science Foundation, which funds a lot of astronomy in the US, might need to be proactive about thinking about how to bring these things back down again. And it's got to be part of the conversation when we're going in to build them in the first place, because you want to be able to promise these communities that when we're done with it, we'll restore it. We're not just going to abandon a decaying telescope on the side of your mountain.
Yeah. And so when I've been learning more about this, listening to your talks, also taking part of this conversation in the Responsible Sighting group, and also studying the history of astronomy, I've been a bit shocked by the fact that when I studied like physics and did research in cosmology and used telescope data, I never heard about this. Like this idea of colonialism, in relationship to astronomy. And then when I started learning more about it, I realized what a massive question it is. And for almost all telescope sites that you look like, they have some kind of history going on there. And in many cases also sometimes ongoing conflicts today. So why do you think that why is this, besides the question of the TMT, but why haven't we been talking about this earlier?
I think it's just a difficult conversation to have, especially in a field that thinks so distantly about these big, amazing objects out in the universe. It's often difficult to reconcile that with the fact that you might be doing damage and the data you're getting might be impacting people in negative ways. There's also this added problem where you talk about data, right? Like a lot of people dealing with the data, they think of it as an abstract object. They don't think of it as coming from really a telescope. It's a thing that someone has just given to them that, they can name the telescope it comes from, but they weren't involved in building it. They weren't involved in they aren't the engineers. They aren't the project leads who are building these things. They're just dealing with the data. And I've found this quite strongly in the field that when I talk about responsible sighting to engineers, to people building telescopes, they care very deeply about it. When I'm talking to people who use the data from telescopes, it's too abstract in some way, shape, or form for them to really feel like it's important to them. It's someone else's job, basically. And that's not a great attitude to have as a field. We need to be thinking more strongly about, if you're using this data, if you're a part of these systems, you're benefiting off of the harms that these telescopes do when they go in. But, you can also be part of this system that benefits the groups that do want the telescopes there, that form positive relationships with them. As I said earlier, I think astronomy is well placed to be this leading field inside physics for what it looks like to be good members of the social community. And so it's a hard conversation to have, but it's a really important one to have. And I think astronomy can make huge difference, not just to itself, but to science in general by leading the way in these kinds of projects.
Yeah, I definitely recognize this statement that you're kind of detached from the origin of the data. It's just a bunch of numbers that you have on your computer somehow, and you don't think about like where they come from.
Yeah. No, I mean, I had similar things when I was doing my physics degree, right? There was this like shut up and calculate idea of like, you're just going for your data and you're just trying to figure out what the answers are. You don't often think about where it's coming from or how to build that. That's someone else's job. Someone else is dealing with all that sort of thing. What I care about is the discoveries that I'm getting out of the data I'm getting.
Yeah, exactly. So what you mentioned now with having this difficult conversation, what should institutions do? I mean, some institutions and funding agencies and new collaborations that are building new telescopes, they are very active about this. But in general, what do you think an astronomy institution have for kind of responsibility if they're not involved actively in the construction of a new telescope?
So I think there's a lot of different ways that we can make this change inside astronomy. One sits with the people building the telescopes themselves, right? That's the sort of work we're doing with the Next Generation Event Horizon telescope to sort of help them decide where to put these buildings. But having people think about these things can also come systematically, right? So it's about the funding bodies pushing for people building them to think about these things, having requirements for funding that means you have to go in and talk to these things. It's about institutions, it's about universities, asking questions about where the data came from, pushing people because a lot of these astronomers work within these institutions, the institution having norms and guidelines for how to interact with particularly things like Indigenous communities, which a lot of institutions now do. More and more of these things are getting put in place. And so they themselves are starting to force the astronomers and astronomy in general to think about these issues. It's about the people working at the telescopes or using the data, questioning these things and advocating for better practices within the field. In general, it's going to be a multimodal whole field shift that needs to happen. And that requires everyone even just occasionally asking questions and checking these things as they go along.
Yeah, so if it is this kind of multimodal shift that needs to happen, one feeling I have, for example, is that when you talk with astronomers or physicists, so my former colleagues at the university and so on, that maybe they are not always the best suited to think about these issues.
Yeah, this is definitely a thing that I've encountered. I mean, so in many ways, it's unfair to force the astronomers to deal with this because they're already experts in a bunch of other things, right? Like if you're an expert in black hole observation or galaxy collision modeling, right? Like if I then add to you, okay, great, but you've also got to be an expert in surveying local communities for whether or not they want telescopes in their backyard. That's an entire other skill set. But the good news is that there are lots of people that have that skill set. And this is where recognizing that these kinds of problems are interdisciplinary in nature, so I'm an ethicist. Other people in our group are social scientists, are historians, are science communicators, are people from an incredibly diverse range of backgrounds who have expertise that can be brought to bear on these problems. So as I sort of said earlier, the earlier you bring in people who know what they're doing in these spaces and have some experience in working with local communities, in doing talking tours, in doing community surveys, in walking around a site and figuring out what the environmental impacts of building something there would be, the earlier they're involved, the better off you're going to be in the long run. So expertise is often just, if you're on a campus, it's often just a building away. It's about stepping outside of our ivory towers inside science and inside academia and reaching out across to other people who have these relevant expertise. Because they exist, they're often more than happy to chat and talk things through and be a part of these projects. So, and realistically, that also often means building in funding space for these people to come in and do their work. It's about making sure that there is money, because it is not free to go in and talk to communities. It's about contacting social scientists and anthropologists and ethicists and historians and recognizing this huge complex networks of things that need to go into being better at working with local communities and minimizing environmental impact.
So suppose you're at a small university and maybe you don't have that local expertise in that university, and I want to build a telescope. Can I give you a call at the Responsible Siting Group? And
yeah, I mean, look, so we're working with the Next Generation Event Horizon telescope right now, but the people inside the group, we're interested in this more broadly. And we've been talking to people, for example, the International Astronomical Union and people at other large physics buildings or LIGO, And so we're all super interested in these things. And like anyone who's thinking about these problems are always welcome to reach out. We're always keen to have conversations. We have this like huge backlog of experts. And even if the conversation just goes great, like here are some resources, here are people you should be talking to. Here's how to get in contact with people in your area who are willing to help. We're so enthusiastic about helping these projects move forward and making sure that like everyone's getting the help they need to be better citizens.
Sounds great. So we're gonna slowly wrap up the conversation, but let's talk a little bit about your experience now. You've been working for how long with the Responsible Siting Group?
About a year now.
Yeah. So what was your like initial condition going into that work, and how has your perspective shifted?
Yeah, it's a super interesting question. So when I first started this, I initially thought I was just going to write a quick paper about this. I thought it was an interesting question, like what are the ethical obligations of scientists when they're building telescopes? And I had some experience coming from synthetic biology, thinking about where to put genetically modified species. And in that space,
synthetic biology, could you just, what is that?
Yeah. So synthetic biology is basically artificial biology, and whatever that looks like. So my own area that I work in that space is invasive species control and de-extinction. And so the idea there is you can go in and like mess with the genes of a species and sometimes revive them from the dead. Essentially, you can reconstitute species from stored genetic material. You can genetically modify mosquitoes so they can't transmit malaria, for example, or genetically modify European rabbits in New Zealand so that they breed themselves out of existence. There's a bunch of like really interesting and complicated topics happening.
Very science fiction, Jurassic
very
Park,
sci-fi, and it's all coming down the line. That's an entire other podcast at some point to talk about.
I would love to talk about that.
All the like fascinating work being done in synthetic biology right now. But one of the big questions for that field is that, especially if you're releasing genetically modified organisms into the environment for whatever reason, whether it's bringing them back from the dead, whether it's invasive species control, whether you're, there's a project right now modifying the American chestnut to make it resistant to a fungal blight that's killing it off. But traditionally, species don't respect national borders. They tend to just wander across lines, which means that if, for example, India releases mosquitoes that are genetically resistant to malaria, those mosquitoes are going to end up in places like Pakistan, the Himalayas. They're going to spread. And so there's a lot of questions about how do you release these, where do you release them, what permissions do you need, and what permissions do you need from people on the ground. There's a project right now attempting to release these kinds of mosquitoes in California. And they're having to go through a lot of processes to think about where do you release these and we're releasing genetically modified organisms in your backyard. Like, are you okay with that? You're sort of going to be a test bed for these kinds of technologies.
How could that possibly go wrong?
I know, right? So I was coming from that angle. I was like, look, like I already think about a lot of these things in these other spaces, and I have a physics degree. I love physics. I think physics is amazing. I love astronomy. So like, let me take this combination of these two, and I want to write a paper about this. And that, it ended up being a year-long process of me ending up in charge of this group, thinking about how to do responsible siting for this big project. And so it's grown from sort of this like interesting project where I was like, let me just like, I'm going to pull some lessons across. We'll like publish some things, do some guidelines to, okay, this is a really complicated thing, especially because it's all well and good to give high-level advice. Say, look, like, go in early, talk to people, make sure you're abundant with your information. We can give sort of these big, broad, like, guidelines, but that's very different from going in and actually sitting on the ground with communities, going into Native American tribal, like, nations and being like, hi, these are your traditional lands. We're interested in building a telescope. Like, would you be okay with that? Working with local governments. It's much more complicated when you're actually having to do that for a group, which is part of the fun. It's been really lovely getting to put a lot of this stuff into practice and feeling like we as a group are making a difference to the way that astronomy functions.
Yeah, you mentioned before this podcast when you were chatting at lunch that you, as a philosopher, you wanted to do applied philosophy. What does that mean in this context?
So it's a complicated question. So philosophy traditionally has been this very like abstract field. I mean, maybe not traditionally. Let me rephrase that. The last 100 years or so, philosophy has been a very abstract field. Prior to that, it was called natural philosophy and it was science. And it was just continuous. Yeah, it was just continuous with science, right? Yeah. And so like as philosophy has sort of succeeded at things like figuring out the laws of physics or biology or psychology. It's sort of sprung these fields off and released them out into the world. And so philosophy has become, in many ways, a very abstract field. We talk about like all sorts of really interesting topics, but it's, you know, very contained within the realm of philosophy and philosophers working with things. Now, there's a growing subset of philosophers, and they never went away. They've always existed, but like there's more and more of a move to make sure that we recognize that philosophy does impact the world around it, that we have a lot of really important insights, especially in places like ethics, where it's very clear what the impact of philosophy is going to be in these spaces, right? Ethicists are directly dealing often with real world problems and real world issues. And so applied philosophy really is about thinking about these incredibly impressive, like with thousands of years of history, like work, and figuring out how to help with real world problems using these structures that we've got inside philosophy. So I really care a lot about doing things that make a difference, about taking these tools and using them in ways that are productive. And the responsible siting is a really obvious and impactful way to help.
Yeah. So what would you... I like this study a lot of applied physics. Applied physics.
Same thing 100 years ago.
Yeah, exactly. Applied philosophy being used in this very, very hands-on way of choosing new sighting sites. And if you could like dream freely, what would this question of sighting look like in, say, 20 years or something?
I mean, in an ideal world, I think it would look like it just being a standard part of decisions, right? Traditionally, the decision of where to build things has been a very technical question, right? You're thinking about optimizing against the height of your like location, water vapor in the atmosphere, how many cloudy days do you get, like access, how much money is it going to cost to build there? And responsible siting would just become one more thing that's part of that checkbox. So, you know, it's standard for funding bodies to expect this to be a part of the conversation. It's standard that you talk about how to bring these telescopes back out again when you're done. It is standard that social scientists and ethicists and historians and anthropologists are involved in figuring out when and where to build telescopes. The dream was that like those things are just what happens every time we do it, rather than it being this exception that we're currently doing at the NGHT. And again, I think we're trending in that direction. There are moves throughout the field and throughout physics in general to try and bring these groups in and have these conversations. I think we're sort of sitting at the start of this right now. And I'm optimistic that in the future we'll get there.
That's great. So do you feel that it's a generational thing also going on now? Or
don't know. I wouldn't necessarily say that. I've met plenty of senior philosophers who really care about these things, and plenty of junior philosophers who really care about these things. I think a lot of it is just what you're exposed to. So if you're talking about the physics degree you had and my physics degree, where we just never had these conversations, right? And so I can't imagine how that would be different if we'd had these conversations in our physics classrooms, right? If this just becomes a part of what it is to be doing these things. And so normalizing it, making sure that it's something we're talking about as a field, like that's a really good first step towards having this be something that we think of as standard. And towards astronomy just doing better.
Sounds good.
I feel like I sort of wandered off on that one.
So we're gonna wrap up. Is there anything I should have asked that I didn't ask, or anything you want to mention before we finish off?
I think we've covered most of the things I think are really important in this space. I mean, I guess it's worth hammering home again that like these aren't lessons astronomy has to learn by itself. It doesn't have to reinvent the wheel. Lots of other areas of science have done this, have gone through these reckonings, are in the middle of these reckonings right now. Things like particularly paleontology and archaeology. You know, I've talked about biology a bunch and synthetic biology, but paleontology and archaeology have spent a very long time having to think about local communities in a much more direct way that are impacted by their excavations, because they're often dealing very directly with people's histories and people's cultures, people's religions as they do these things. And so we're not alone in astronomy and having to deal with these struggles. It's something that we can look to other fields to figure out, and we can build on what they've been doing in really productive ways. And it's gonna be a hard conversation, but I don't think it's a impossible one. I don't think it's not impossibly difficult to do. Well, that's a bad way. I don't want to imply this is a difficult thing. What I want to say is that like astronomy can borrow from these other areas of science in ways that are really helpful. and like that give us this boost up, and we can just start doing this going forward. This should be a standard part of what we're thinking about in the field.
Learning from the paleontologists.
Learning from the paleontologists. Just grabbing some archaeologists from your local university and being like, what are you guys doing these days? Where are you guys sitting when it comes to responsible siting issues?
Exactly. Okay, I think this has been a fantastic talk, and
yeah, thank you for having me on. This has been really fun.
Yeah, thank you for telling about all of this. And if someone listens to this and feels like, wow, I really want to get engaged with the responsible siting group, can one do that?
Yeah, they're welcome to reach out to me or anyone involved with the Next Generation Event Horizon Telescope or the Black Hole Initiative at Harvard. They'll be able to direct you towards us. There's also some good stuff happening at the International Astronomical Union and some other places around that are thinking about these things as well. So the resources are out there. We're always happy to chat about these things and expand the work we're doing.
Perfect. And I'll put links also in connection with this podcast. Great. So, Ann Thresher, thank you so much for telling us about the responsible siting in astronomy.
Yeah, thank you for this. It's been great.